Hello everyone and welcome back to Data by Design. Today we continue our mapping of the data market at large and will specifically focus on the first quadrant of our schema, namely the static data quadrant. This quadrant contains a heavyweight category, data storage. In this super category of databases, we find several subcategories often classified by their technology. Relational databases store information in the form of tables and columns and are queryable using SQL language. A subcategory of relational databases is the data warehouse. Let's mention some giants in the market: Oracle, SQL Server, DB2, PostgreSQL, BigQuery, Redshift, and of course Snowflake. Data lakes are databases that allow storing information in the form of files, often in a centralized way. This was particularly the case for the Hadoop revolution and similar technologies. Current tools include Azure Data Lake Storage, Amazon S3, Google File Storage, and so on. Graph databases allow tackling different challenges, such as fraud detection by the ability to identify patterns. Some tools in this category include Neo4j, TigerGraph, and others. And there are still other storage categories, vector, in-memory, but I won't spend more time on them as we could spend hours discussing them. Nonetheless, databases should not be considered merely as a tank into which information is poured. The data we store can be organized to simplify navigation, like through directories, schemas, buckets, and so on, can be subject to constraints, formats, uniqueness of values, references, the possibility of remaining empty, and whatnot, and are subject to rules of access control or sharing, and more. Let's get back to the car infrastructure metaphor to explain the data infrastructure. We saw that static data could be compared with the car parking. Just as there are many ways to park cars, there are various methods to store and manage data, each tailored to specific needs and goals. Imagine different parking scenarios as analogous to data storage strategies. Reserve parking. Much like reserve parking spots in a lot, relational databases provide structured, designated spaces for data. This arrangement facilitates easy access and management, especially for specific types of structured data, akin to designated spots for different car models. Open parking lots. Comparable to a large open parking area, data lakes offer a vast flexible space where a diverse array of data, regardless of its format, can be stored. This is similar to an open lot where any vehicle from motorcycles to trucks can find a spot. Short-term parking can be compared to caching systems. This is akin to the short-term parking found near airports, designed for quick access and temporary use. In the data world, caching systems temporarily store data for rapid access, improving efficiency for frequently accessed information. Long-term parking. Just like long-term parking facilities at airports, data warehouses are designed for the data storage and retrieval of large volume of data over extended periods. This facilitates in-depth analysis and reporting, much like how long-term parkings accommodates travelers on extended trips. Each of these parking scenarios offer different benefits, such as ease of access, security, or specialized spaces for different vehicle types. It corresponds to data formats. Similarly, in data management, the choice of storage and organization method depends on the specific requirements for access, retrieval, and security, and the nature of the data itself. If this felt like a trip down the rabbit hole of data storage, wait till we explore the other zones. Like, subscribe, and gear up for our next deep dive. Stay analytical and see you soon.